Okay, permutations and combination lesson 2, factorial notation and permutations. Consider how many ways there are of arranging 6 different books side by side on a shelf. Use the fundamental counting principle. We calculate the product to be 6 times 5 times 4 times 3 times 2 times 1. In mathematics, this product can be written in simplified form called factorial notation. So 6 times 5 times 4 times 3 times 2 times 1 is denoted by 6 exclamation mark, pronounced 6 factorial or factorial 6. Without using a calculator, determine the value of each. Well, 4 factorial, so we just start with 4 and we decrease by 1 as we go. So 4 times 3 times 2 times 1. Well, 4 times 3 is 12, times 2 is 24, times 1 is 24. 3 factorial times 2 factorial is 3 times 2 times 1 times 2 times 1. Well, 3 times 2 is 6, times 1 is still 6, times 2 is 12, times 1 is still 12. So this gives us 12. Notice that 6 factorial can be written in a variety of ways. So we can write 6 factorial as 6 times 5 times 4 times 3 times 2 times 1, or 6 times 5 times 4 times 3 times 2 factorial, because this is really saying times 1 after it, or 6 times 5 times 4 times 3 factorial, because that accounts for the times 2 times 1, and so on. The table above can be used to help us simplify quotients such as 6 factorial over 4 factorial. So we know we can rewrite 6 factorial as 6 times 5 times 4 factorial, which means the 4 factorials can cancel each other out, leaving us just with 6 times 5, so that equals 30. Now on your calculators, you can type in this factorial button. I just need to see where it will be. So on your calculators, so I'm just on the scratch pad or calculator screen. I can type in 6, then hit menu, go down to number 5, probability, and it's choice 1 there, factorial. So, and it is just the exclamation mark there. So, B, express 5 as a product in 4 different ways. Well, 5 factorial can be written as 5 times 4 times 3 times 2 times 1. Or it can be written as 5 times 4 times 3 times 2 factorial. Or 5 times 4 times 3 factorial. Or 5 times 4 factorial. C, complete the following. 12 factorial equals what times 11 factorial? Well, remember 11 factorial is 11 times 10 times 9, etc., all the way to 1. So to make this into 12 factorial, we would just need to multiply by a 12 out front. What about the second one? I need to get to 8 factorial, but right now I just have 6 factorial, so that's 6 all the way down to 1. I need to go 8 all the way down to 1, so I need to add 8 times 7 out front. Express as a quotient of factorials. Well, I need 6 times 5 times 4, if that's what I'm left with. If I started with 6 factorial, because that's my highest one, but I'm missing here, or I've crossed out 3 times 2 times 1, so that means I've crossed out 3 factorial. Same idea here, 15 times 14 times 13 times 12. So 15 is my highest number, so that must mean I started with 15 factorial, but I've crossed out 11 times 10 times 9 all the way down to times 1. So that means I must have crossed out 11 factorial. So to simplify these, the key is use your denominator there to guide you at what we need to cancel out, or how we would rewrite this first one. So I'm going to expand this 10 factorial all the way until I get to 7. And then I can just write 7 factorial. Now I can cancel out the 7 factorials, leaving me with 10 times 9 times 8. Well, 9 times 8 is 72, times 10 is 720. Okay, now here I have 8 factorial times 5 factorial times 3 factorial. Well, this one's a little bit trickier, but I can go 8 times 7 times 6. Well, now I'm at 5, so I'm going to write this as 5 factorial. So now I know I can get rid of the 5 factorial, but I still have a 3 factorial on the bottom. So let's see if there's any way I can cancel that out. Well, 3 factorial, remember, is 3 times 2 times 1. Well, 3 times 2 times 1 equals 6. So this actually cancels out with that, leaving us just the product of 8 and 7. So this equals 56. In general, n factorial equals n times n minus 1 times n minus 2 times n minus 3 all the way down to 1, where n is a natural number. So we can't calculate the factorial of 2.5. We only calculate the factorial of positive whole numbers. 0 factorial is defined to be equal to 1, and the reasoning is described later in the lesson. So n factorial can be written as the product in many ways. So all this notation is saying is we take our number and we continually multiply by decreasing by 1 numbers until we get down to 1. So complete the following. N factorial equals blank times n minus 1 factorial. Well, n minus 1 gets us to one number smaller than n, so to get this to n factorial, we would just add an n. N plus 2 factorial, well, it's already given me n factorial, but I need to go 2 numbers higher. So that means I need to multiply by n plus 1 and multiply by n plus 2. So now I'm starting from n plus 2 and multiplying by decreasing by 1 numbers. Okay, and this one here, it has n minus 4 times n minus 5 times n minus 6 all the way down to 1, which means our largest number was n minus 4, and we multiplied by numbers that were decreasing by 1. So this is n minus 4 factorial. Simplify the following expressions. Leave your answer in the product form where appropriate. So here I have n plus 2. Well, if I expand this out, I'm going to decrease by 1 until I get to my denominator. My denominator was n, so I have n plus 2 times n plus 1. Crossing out the n factorial leaves me with n plus 2 times n plus 1. Sometimes we'll expand these out. We're just going to leave this as factored form right now, though. Here, so we have n minus 2 factorial, so I start with n minus 2. And I could expand this down. But as I do this, I see that, well, now I'm going to go n minus 3. And I'm actually getting smaller than this. So that's not helping me here. So we're actually going to leave the top here as n minus 2 factorial. And this time we're going to work with the denominator, because that's the bigger one. So you always want to start with the biggest one. So this is going to be n minus 1 times, well, my next number would be n minus 2. But that's what I have on top, so I can stop there. Now I can cancel out my n minus 2, so this leaves me with 1 over n minus 1. See, well, now on the bottom I have n, and I have n minus 1. So let's look at what the expansion here looks like. So n factorial is n times n minus 1 times, I could keep going, but I don't have anything in my denominator smaller than n minus 1. So now you can see that I can cross out the n and the n minus 1. So this is equal to n minus 2 factorial. The hardest questions you'll see are something like this. Algebraically solve the equation n factorial over n minus 2 factorial equals 42. So I'm going to do the same thing. I'm going to look at expanding my numerator by decreasing it by 1 till I see something that's found in my denominator, which is n minus 2 here. This equals 42. So now I can cancel out those factorials. So I have n times n minus 1 equals 42. This is really a quadratic equation, because this is really n squared minus n equals 42, or n squared minus n minus 42 equals 0, giving me the factors n plus 6 and n minus 7, which gives me the solutions n can be negative 6 or 7. However, we know that we can never have a factorial using a negative because n is a natural number here. So since n is a natural number, we can get rid of -6, so n is 7. So we can't take the factorial of a negative number, so we have to eliminate -6. So many calculators have a factorial key which can be used. So again, you go into your menu when you're on your calculation screen. You go into your menu, so calculate, into the menu, go down to number 5, probability, and it is the first choice there. So when you punch this in, you should get 720 for 6 factorial and 362,880 for 9 factorial. To simplify a quantity like 10 factorial on a calculator, we can evaluate numerator and denominator separately and then divide, or enter it in one calculation using brackets. It's going to be a lot easier to do it in one calculation as long as you have the brackets. So for example, here you'd want to make sure you have brackets around your denominator. So either way, you're going to get 120. To verify without a calculator, they've expanded it out for us, so we'd see we could cancel out the 7 factorials here. That would give us 720 over 6, which does simplify as well to be 120. So calculate the value. So we're just punching these into our calculator. You should get 74,046 here and 66,045 here. So those, just punching them in. Just make sure you put brackets if you got 2 together like in B. You might want to try some of these assignment questions before we go to the next part, or it's up to you. You can keep going with the lesson here. So an internet site access code consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order. The order of the arrangements of the digits is important. John cannot remember the access code except that the digits are 3, 5, and 7. List all the arrangements of these 3 digits that John could use to determine the access code. So we know 3, 5, and 7, so I'd start with, well, if 3 is the first number, I have the choices 3, 5, 7, or 3, 7, 5. If 5 was the first number, I'd have the choices 5, 3, 7, or 5, 7, 3. And if 7 was the first number, well, then I'd have the choice of having 7, 3, 5, or 7, 5, 3. So there are 6 possible arrangements to consider, and only one of them will access the site. This type of arrangement where the order is important is called a permutation. A permutation is an arrangement of a set of elements in which the order of the elements is important. This is a key part to the unit. One of the hardest parts of this unit is knowing whether order is important or not. So you have to think like this. Does it matter what order I put the digits in? In this case, it does. So permutations of n different elements taking n at a time. So list all the arrangements of the letters of the word cat. Well, we could have cat. We could have CTA, or if the A's first, we could have ACT or ATC. Or if the T's first, we could have TAC or TCA. Write the number of permutations in factorial notation. Well, this is 6. Factorial notation is 3 factorial. You can also think of it like we did in the last example and saying, well, I got 3 letters, so I have 3 choices for the first one, 2 choices for the middle one, and 1 choice for the last one, which is 3 factorial. The number of permutations of n different elements, this is going to be a key word in a few minutes here. So n different elements, or it'll be keyword come tomorrow, n different elements taken all at a time is n factorial. Determine the number of permutations of the letters of each word. So I want to check, are these unique letters in Regina? Yeah, I have 6 unique letters. So therefore, the number of permutations is 6 factorial or 720. So you could also do this with the fundamental counting principle. For Kelowna, again, here I have 7 different letters. So the number of permutations is going to be 7 factorial or 5,040. Permutations of n different elements taken r at a time. Use the fundamental counting principle to determine how many three-letter arrangements can be made from the letters in the word graphite. So here I'm only making three-letter arrangements from a total of 8 letters. So I'm going to go the fundamental counting principle. I have 8 choices for the first one, 7 choices for the second one, and 6 for the last one. So I have 336 choices. In the example above, we have found the number of permutations of 8 n elements taken 3r at a time. This is denoted by 8p3. I often say this is 8 place 3, because I know I have 8 choices and I need to place 3 of them. 8 place 3 equals 8 times 7 times 6, which is the same as 8 times 7 times 6 times 5 factorial, which equals 8 factorial over 8 minus 3 factorial. This is a formula for it, and it is on your formula sheet. It is on your formula sheet, so you don't need to memorize this. The other handy thing, though, is your calculator can calculate this. So to do this on your calculator, from your calculate screen, you're going to hit your menu button. And again, you're going to go to that probability menu. So then you're going to go to 5, probability. From there, you're going to go down to 2, permutations. And then your screen is going to give you something that looks like this, NPR, and it's going to give you brackets. And there you're going to write in your N value, which in this case is 8, comma, your R value, which is 3, and it's going to give me 336. So your screen's going to look like this, NPR, and it's going to give you your brackets. And you're going to type in your N value, which is how many you have to choose from, followed by your R value, which is how many you're placing. So I verified that on the calculator. So defining n equals 0 when we're defining 0 factorial. So when n is 0, what does this equal? So if we replace r by n in the previous formula, we get the number of permutations of n elements taken n at a time. This we know is n factorial. For this to be equal to n factorial, the value of 0 factorial must be 1. So we know if we have 8 letters and we are placing all 8 letters, we're going to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same as 8 factorial. But in our formula here, it does force us to divide by the factorial of 0. So as a consequence of this formula, 0 factorial must be defined as 1. So that's kind of something you need to remember. Of course, you can punch it into your calculator and it will give you 1 as well. Example 6. In a region, vehicle license plates consist of 2 different letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, determine how many different license plates are possible by the fundamental counting principle. So I have 2 letters and 4 digits, so that means I have 6 things I need to fill in here. Consists of 2 letters and 4 digits. So I can't use the letter I, O, Y, and Z. So that means I have 22 choices for the first one and 21 for the second one, because it's 2 different letters, followed by 4 different digits. And again, it says different, so that's implying that I can't repeat. So I'm going to go 10, 9, 8, 7, which gives me 2,328,480. If I were to do this in permutation, so here this word and becomes important again. So I need to choose 2 letters and 4 digits. And the order matters, so I'm thinking I'm placing them, so it is a permutation. So that means I have 22 letters to choose from, and I need to place 2 of them. And, so that means multiply, I have 10 digits, and I need to place 4 of them. So I'm going to go 22p2 times 10p4. Simplest way is to just punch this into your calculator using the permutations function, and of course we get the same answer. You could use the formula as well, but it's a lot simpler to use the function on your calculator. Questions like this is when we do need to use the formula though. So algebraically solve the equation n minus 1 p2 equals 90. So my formula for a permutation is n factorial over n minus r factorial. So here, n in our equation actually equals n minus 1, and r equals 2. So I can substitute into the formula as n minus 1 factorial over n minus 1 minus 2 factorial. Well, this is n minus 1 factorial over n minus 3 factorial. So I'm going to simplify this and then I'll make it equal to 90. So as I simplify this, I can write this as n minus 1 times n minus 2 times n minus 3 factorial all over n minus 3 factorial. So those cross out. So now I'm left with n squared minus 3n plus 2 equals 90. That's the equation I'm trying to solve. So that means n squared minus 3n minus 88 equals 0. So that gives me the factors n minus 11, n plus 8. Which gives me the solutions n equals 11 and negative 8. I know I can't use a negative number in a permutation. How would that make sense? I can't have negative 8 choices for things, and I need to pick 2 of them. So therefore, n equals 11 must be our solution. In many cases involving simple permutations, the fundamental counting principle can be used in place of the permutation formulas. So you need to decide what you like better. To me, the fundamental counting principle makes sense, especially if I'm talking about rearranging things, but the permutations work just as well.